Okay. We'll come back again to module 2, where we're still talking about using matrices, eigenvalue, eigenvector to solve a set of equations, either linear. We'll see soon how to solve set of differential equations. And still talking about eigenvalues and eigenvector. I will take more examples here, okay, to practice the same point, okay. So let's take the first example. Today I will solve problems more, okay. Find the characteristic polynomial of this matrix. He gave me the matrix A. It's 2 by 2. As you can see, 3 minus 1 minus 1, 3. And I know that the characteristic equation say A minus lambda I equal 0, right? So I substituted A. This is A. And this is lambda. And this is I. Definitely when I multiply lambda, it means it will be here lambda and lambda. Okay, so when I subtract, definitely we'll say, okay, 3 minus lambda minus 1 minus 0 minus 1 minus 0, 3 minus lambda. Determinant 2 by 2 is easy to find. Multiply these two items minus these two items. Very simple. I reached here. You need to consider these signs, okay? The remaining is just method of math, but make sure you don't fail you don't have mistakes here, because you have different items. Use brackets, it's free. Okay. Now I open the brackets here. I got quadratic equation. Okay. Now I solve this quadratic equation to find the eigenvalue. I solve it. We know how to solve a quadratic equation from secondary school and foundation level. We're still using the same formula. If it is easy to use the factorization, go ahead. Otherwise, use the quadratic formula. I got two eigenvalues. This is the first one, and this is the second one. And this is the answer for this question. Another question. What I did here, I just changed the numbers. Oh, does this mean that we have a procedure we just need to follow? Yeah. You practice more, you get the experience. Have a look here at this matrix. He gave me matrix with 1, 2, minus 1, 4. And he told me that find the characteristic equation. Okay, what else? Eigenvalues for this matrix. Okay, now characteristic equation, I need to find delta. Okay, that in this way, A minus lambda, the same one. You see, this is A, this is lambda, this is identity. Subtract, I approach here. Now let me multiply these two items minus these two items. I approach here. Simplify, you get the characteristic equation. Characteristic equation is the equation contain lambda. When I solve it, I found lambda, which is the eigenvalues. I got two eigenvalues, one of them 2, one of them 3. Now let me add something to this. Let me say the question. For this lambda, we can find eigenvector. I gave you here the eigenvector. Okay, I leave the remaining muted. I leave the remaining for you to practice, similar to the example solved last week. The same thing for this lambda, you can find the eigenvector. And since we are talking about eigenvector, okay, let me solve a problem how we find eigenvector. We solved last week few problems, but let's practice more. I have another matrix, which is minus 3, 2, minus 2, 1. As usual, I write the determinant, which represents the characteristic equation, this one. I substituted A here, minus lambda I here. Subtract, I got these 4 items. Multiply these 2 items by these 2 items to get the characteristic equation. This is my characteristic equation. Lambda square plus 2 lambda plus 1. If I solve it, what I find? I find eigenvalues. Let me say I solve it and I found 2 eigenvalues. These eigenvalues is minus 1, repetitive. You see here? It's repeat twice. Now for this lambda, which is -1, can we find the eigenvector? Yeah, we can. What is the rule? The rule say Ax equal lambda x. Very simple. Okay. Now, if we take this part to the other side and subtract, we will have again A minus lambda I equals 0. Okay. Now have a look. Have a look. This is the A minus lambda I. If we multiply it by x1, x2, let's see what we come up with. What is the value of lambda? Just a minute. -1. So minus 1 plus 1, -3 plus 1, -2. This 2 and this -2, we keep them. 1 here. 1 minus lambda, minus plus lambda, which is 1, it means 2. I got this formula. Okay. This formula here, x equals 0. Now I will multiply this row by this column, which give me 0. The same thing, this row by this column, which give me 0, as you can see here. Let me simplify. I will take this one to the other side. It will be -2 equal, sorry, x1 equal -2 x2. So -2 with -2, x1 equal x2. So whatever the x1 will be, let's assume x1 is t. Then x2 will be also t. So I can write x to be x1, x2, which means t, t. I can take it as a common. What is left? 1, 1. This is what I'm looking for. This is my eigenvector. This eigenvector is related to this eigenvalue. Now, we understand how we use the characteristic formula to find the characteristic equation, then solve it to find the eigenvalues. For each eigenvalue, we will solve to find eigenvector. It's a procedure we follow. Numbers could be changed, but the procedure is the same. Now, another property we need to discuss here, because we will use this one in solving set of differential equations. Have a look, have a look. Diagonalization. Let me read the definition, explain it, and then we go for example to clarify it. A square matrix is called, it's supposed to be square matrix, diagonalizable from diagonal if there is an invertible matrix P such that P inverse the matrix A by P is a diagonal matrix. The matrix P is said to be diagonalizable or diagonalize A. Let me explain this through example. Have a look. He told me find a matrix P that diagonalizes a matrix A, and he gave me this matrix A, which is 3 by 3. Okay. I will go through the procedure to find eigenvalues and eigenvectors equivalent to these eigenvalues, similar to the previous examples. Have a look, have a look. I will come, I will say, okay, determinant A minus lambda I equals 0. I substituted A by this one. I identity lambda, which is lambda 0, 0, 0, lambda 0, 0, 0, lambda. I subtract, I simplify. I use a cross product as example to find the determinant. Then what I got this formula. Let me say I got this formula. Now this is the characteristic equation. I will say, okay, either lambda minus 1 equals 0, which means lambda equal 1, or lambda minus 2 equals 0, which means lambda equal 2. So I have 2 lambda here, as you can see. 2 is repetitive because it's repeated twice. Okay. Now, for lambda equal 1, I will go through the same procedure to find eigenvector. I came for lambda equal 1, I got this eigenvector. I repeat the same thing for lambda equal 2. I got 2 eigenvectors. This is 1, this is 2. Now, if I put them together, this eigenvector with this eigenvector with this eigenvector in this way, what we got? We got matrix. This matrix P which contain these eigenvectors is the diagonalized matrix A. Diagonal is a matrix which diagonalize matrix A. What does it mean? It means, have a look. I have P. This is P. I have A. This is A. If I find P inverse of this one, P inverse, we know how to find P inverse. Okay. Let me say I went through the methods to find P inverse. This is P inverse, and this is A, and this is P. When I multiply them, I go to new matrix. The new matrix is a diagonal matrix. It means only in the diagonal we have numbers. Otherwise, 0. All other items are 0. But this diagonal contain the eigenvalues. Oh, just a minute, let me back. What I have 2. And 2 repeated twice. It means 2, 2, and I have 1. Just a minute, let me see. Yeah, correct. 2, 2, 1. You got it? Let me repeat again. I went through the characteristic equation. I got lambda. It could be 1 lambda, 2 lambda, 3, whatever they are. Then for each lambda, I got the eigenvector x. I put them together to got P. Now I got P inverse also. So if I put them in this way, P inverse A, P, the new matrix is a diagonal matrix which represent lambda 1, lambda 2, lambda 3. Other items are zeros. This is called diagonalizable property, and the matrix is diagonalized matrix A. Okay, let's take this example. A matrix that is not diagonalizable, he told me that this is A. See if we can find the diagonalized matrix for this one. I go through the same procedure, determinant lambda I or A minus lambda I. I reach here, I solve it, I got the characteristic equation, I solve it, I got 2 eigenvalues. These. I solve eigenvalue, the first one, I got this eigenvector. I solve the second one, this one, I got the eigenvector. When I put them together, just a minute, 1 over 8 minus 1 over 8, 1, and the other one, 0, 0, 1. Let me ask you a question. Is this matrix square matrix or not square matrix? What do you think?
Not square matrix.
Excellent. It is not square. It is 2. It's 3 by 2. You see here? 3 rows by 2 columns. 3 by 2. So it is not square matrix. But just a minute. He told me in the definition that it's supposed to be square matrix. So I will say, okay, then this is not diagonalizable matrix. One more problem here. We are given this matrix A. Okay. We solve it. We got 3 lambda. This is 1. This is 2. This is 3. Okay. Then it is diagonalizable. I can write the relationship P inverse AP in this way. The first number, the second number of the eigenvalue, the third number of the eigenvalue. Now, sometime if the matrix is large in size, as example, this is 4 times 4. I don't need to talk about here more because we mentioned that we go for the row or column which have the highest number of zeros. So I take this column for determinant or this column, which at the end make my task easy. Okay. I advise to spend some time at home solving these 3 matrices as exercises. And just to let you know, the second session this week, I will talk about how we solve differential equation. it mean we know that dy over dx, let me say, equal to x plus 7. This is called differential equation. Why? Because my subject y has been differentiated with respect to x, whatever the variable. When I solve it, it means getting back to find y. So at the end, I will integrate, because here it's differentiated, integrate to go back to the original y. We will solve differential equation first and second order. We will spend the remaining 6 weeks only solving these type of problems. But here we will learn how to use matrices, eigenvalues, eigenvectors to solve these equations. So the second part will be related to solving differential equation using matrices. Now what I will